And that's what this Google Sheet is.
All right, I went ahead and recorded things just in
Yeah.
case.
That's what this Google Sheet is. And one of the outcomes of this meeting would be if this sheet is incomplete in any way, if there's other things on here. Can I share the location of this Google Sheet?
Yes,
And that way folks could look at it.
Can you put it on the Slack?
You want me to put it on the,
yeah,
rather than the chat window?
either one. If you put it in chat, I can put it in Slack.
Yeah.
Thank you.
I mean,
Let's
you
do
see,
that.
most of us are not in Zoom chat like that.
Yeah. Also, Zoom closes and it's gone forever.
Yeah,
Yeah.
that's true.
But we get 90 days.
Oh, request access.
You don't have access to that spreadsheet.
Yeah, I'm working on it.
Is this combined, it's the free Slack? Yeah. Okay, it's 90 days.
Yeah,
That's okay.
it's acceptable.
Does that work?
Nope, still need access.
I think. Still no access?
Correct.
Just
There we
There you
go.
go.
Now I'm in the right place.
And then you can change the viewer to editor if you want people to edit.
anyone with blanks?
So I,
So the lower right there, it says viewer. So right now everyone can view. If you want people to add to it, like,
the interesting thing is,
You should. As a chat window in the middle of the screen.
yep, if I have to click on that.
Oh, okay.
There we go.
okay. So
Oh, and now I have to put this in. I'll put it in the hard
switch over, oh, I see.
there.
So yeah, so this is a list of things and you know, I'll just flash up on the screen. Oh, I should share my full screen. Instead of that. Um. Let me just share, this document. So at EBI in 2017, tremendously long time ago. Somebody, a postdoc, actually, I remember talking about this, created this wonderful document. And here's the name of the, and 2017. And it's got a breakdown of all of the annotations. Species reaction models for biomodels. And I would love it if somebody would redo this. I mean, it's just kind of some scripting work, but at any rate, this gives me a list. If we look at the species, this gives me a list of the most common annotations for the model. This is the model right here. Which is, you know, gene ontology, uniprot, taxonomy. What does this model, what species, what model organism does this model deal with? SBL and PubMed and KEBI. Although the KEBI mostly comes from has part, which is also pretty weird. But at any rate, I think PubMed is one of the most important resources for the model. For species, uniprot, KEBI, KEG compound, KEG gene, and then other things at lower level. And then reactions, gene ontology and the EC number and KEG reaction. What's interesting to me about this, and I hope this is dated, is that RIA is not used, which is very strange to me. Since I think that's a better resource, but
Was it there in 2017 or was it there like
it
back?
was there in 2017, but I think it was new.
It was, and so, yeah, this was to be the annotations for all the biomodels in history, so.
And so, and I'm not just interested in biomodels, I want to emphasize that. I
Yeah.
also have looked at Big and other places. And so, for example, Big annotates against all kinds of things. This is a metabolite, but if we look at a reaction, we look at a reaction, most of the reactions are annotated against RIA. Well, some of the reactions, I should say. The annotations are here. Annotated against biopsych, which is something interesting, and biopsych is not annotated against at all in biomodels. And I'm not sure why, except that biopsych does have a lot of metabolic information, which is what big focuses on, as opposed to biomodels. But, well, yeah, trust me, somewhere in here, they often use React on. Let me pause right there and say that's the general goal of this, is to think about these different resources. And do you have any comments or additions or questions?
I think it'd be really interesting to know what are the, does biomodels and big, do they have, when they train somebody to annotate, what are they trained to do? What are their policies? Do they, does big intentionally, do they want to have annotation against multiple knowledge resources? Why? In biomodels, is that not the case?
Yeah, like how much is training and how much is inertia,
Yeah.
it's like, this is how we started doing it, and so we're continuing to do this.
Right, what's the rationale,
Yeah,
or is it just sort of like up to the individual annotator,
Yeah.
People look at open activities. You get people utilizing these things, so you can create a measure on all of these to help make this. We have this problem with other. This thing defines this one defines this. But I like to just define it in equivalent, so it doesn't matter what I find. I've got some meta ontology that I can do my thing with. I really what ontology you use. So know that it's the right thing. We all do the same thing.
Well, that sounds good. So what you're asking about is some way of knowing which resource to use and just letting somebody else worry about linking the resource. So in some cases, some resources do have problems. And that's something I would like to actually capture in this session, is to figure out, or maybe not in this session, but at some point it'd be good to know what things reference each other. So KEGG compound and KEBI, for example, I believe there's a one directional link. I think it's from KEGG. At any rate, so some resources possibly do so. But the real problem is that, in my view, and this is why I think you should model annotate against more than one thing, is that the information available in resource A is different from the information available in resource B, even if they're talking about the same thing. So, depending on your goals for annotation, but if your goal for annotation is to make your model as widely accessible to the largest group of people, I think it might be good to annotate against multiple things. Because the community that looks at KEGG might love KEGG because they have some particular sequence information. Versus the community that loves KEBI might love KEBI for a different reason. And the information in KEBI is not the same as the information in KEGG, even if you're talking about the same object.
so like what it references, but just the local storage of information like charge or sequence or.
Yeah, what they choose. I mean, we can look at some examples.
Yeah, no, I mean, like that's the thing, like you're talking about the same thing sometimes it's hard, there's in a bit of action, it's like, overlap.
Right,
It's kind of the same thing.
right,
This
Yeah.
way, how you describe that,
right.
and it's still in my place.
So there is,
The same thing with it.
so in Combine, there's this notion of is version of and has version, right?
Yeah.
So if the thing in your model is a more specific version of something that's elsewhere, then you can say that explicitly, or the more general thing. If it's cobbled together, it's neither more general nor more specific, that's a little trickier. Is that what you're getting at?
Yeah, so this is a bit where I struggle with the annotation side, striving application I should be using to capture the knowledge that I'm trying to capture. It's like, which one is this? And back it up and think talk nonsense. Or something you think is one way, and someone else reads it another.
So what resources specifically are you talking about?
Oh, but we do it with, and what we're looking, particularly for our sparks, like neurons, stuff like that, and places in the body. We're trying to describe,
So Uberon, you know, I didn't write down Uberon.
and like anatomy wise, this guy's pulling it back, and this guy's referring, this one pulling G, and slightly to the left of that one. We the same thing, are we going different places?
So do you use Uberon or do you use FNA or
We're on FMA,
both of those?
that's the-
Or mouse anatomy?
things that don't exist. We have to-
There's an intermediate, but it's the very end, my zone.
Oh, what's that?
You end up making all the identifiers there that eventually might end up doing wrong.
So is that-
There's a things that don't exist in ontology.
It's things in anatomy that people have never needed to describe before.
Okay,
Yeah, and that's definitely something that we've come across before, and I think in the harmonizing paper, you know, the one where we make recommendations. We talked about term requests, we're gonna talk about. where,
Right.
Like there needs to be some kind of, you know, pipeline to make that happen in auditors and formal developers, so that, because, yeah, modelers, you know, they'll, you know, compartmentalize things weirdly or compared to what managers will do. You know, they group things together and for their models work, right?
The big thing for us is now that we're trying to put these things together, and so we're trying to use on polygons, it's like this thing and this thing the same. We can start fitting them.
Right.
And sometimes like, we want to fit that thing, but what is it called? Who's gonna tell me what this thing is called? I need this line, I need this edge of this organ. Who's gonna tell me what it is? One person tells me it's this thing, and now tells me it's something else. You know, it's like, there's stuff like that.
Well, I mean, I think that's actually,
Bad stuff, you're trying to use this information to do that, so I can just say, well, this thing is the same, I can fit it in my problem, all the same terms, people describe nicely.
so that's a use case where you should annotate against both, right? So if the anatomical object you're talking about is described in two different ways by two different resources. Probably a good idea to include both pointers.
Yeah, it is one thing, the other thing is, how do I handle that?
Yeah,
yeah,
that's a term request. I think that's a term request. And I'm surprised to hear, I mean, I guess it does happen, but it shouldn't happen that often. It happens. a lot.
That's all.
So you, someone does imaging, they say this is the heart.
Right,
And I want to register that data to my finite element model. I need to know that's actually the outside surface of the left ventricle. Rather than just that heart data.
but Uberon has the outside surface of the left ventricle.
So, yeah, that's a bad example.
Think about it, because it's not, it's actually.
It's much smaller than
You can tell,
than
and
that.
everything is not, you need to be a lot more careful and accurate in what you're calling things, because when it comes to fitting things like the heart, which are pretty horrible to fit.
Right.
This seems like science though, like research, right? Like, we don't exactly know the categories yet. You know, like, we know some of them, but like, you know, you come upon a new phenomenon, you have to, like, it's new. So there needs to be a flexible way to say I have a new kind of thing
So,
here.
so for example, maybe one of the things you're interested in, surface that is innervated by this particular, artery or nerve. And that's gonna be a subregion of the surface of the left ventricle. Right?
I mean, that gets even, that's where it starts getting really fun for us, that we've got the outer surface of the ventricle, we only want up this region of it, how do we
So-
drive that region?
Right, so that's where I think as Kanan is saying, we don't want to canonize that as an anatomical term. Instead, I think for the purposes of annotation, you just have to say, it's a subregion of. So we could certainly put a description saying, you know, this term in my model is a subregion of.
Yeah, I think that particular thing is getting away from them.
Okay,
But with the problem that we're having is because matching two, for some people will be one or some people run those in fact, and we want to go like back. This guy saying let this go over, or this guy saying let this go and.
Yeah.
And we want to go right. Want to call it the same thing, we actually.
I'm curious to know, have you guys looked into, BioPortal?
Right.
Resource that's supposed to do this kind of mapping, to explore that, do those mappings exist, or?
So this is BioPortal.
We're still trying to get people to. Annotate stuff actually enough so that we can. Read all of these things.
Next, here it is, mapping. So I think you can just go to BioPortal's mapping.
I think especially for like anatomical.
For
ontology,
Uberon and FMA, yeah,
there might be some good mapping, some thorough mappings.
Yeah, so I mean, this is, do we try and annotate things with multiple annotations? Or do we have software that's better at looking at mapping?
Right.
Right, this is what we're doing, we're looking to. Steve, that's where we're at right now.
well, I might recommend this tool. For that, it's kind of a manual. So, well,
Does it have like a REST
it
API?
does have an API,
So you could just, yeah.
you could call it,
Are these like undergrads going in and just?
It's all sorts of people. I mean, but so Spark, I mean, we have the advantage that the data is all heavily curated and they expect curators to go through and eventually. fix it. So try to do something.
But there's being able to equip live these things with a tool that you they have like say you're going to use this stuff. You might find it. That would help.
so there are 4,600 terms that are mapped between. The foundational model of anatomy and Uberon, it seems like a surprisingly small number to me. Yeah, here you go. Interesting. I've never looked at detail of this. But I believe there's an API to this, and so this could tell you. The mappings between particular terms in Uberon, which is on the left, and the FMA, which is on the right.
Does anybody know if these kinds of mappings exist in identifiers.org? Are they working on, such mappings?
I feel like the,
API has it, so.
Yeah, right, their ontology, database.
speaking of, Sharif said that he was gonna be putting his kids to bed and then we'll try to join in about half an hour afterwards.
Okay.
Right, so.
So I think species or physical entities is one places where there should be a lot of ability to map across resources. And it would be good to know, so, I'm not proposing we do this now, but it would be good to know what things cross-reference what things. So that, we would know
Yeah,
whether K top references Unicode or.
so the advantage of just putting everything in the model means that whoever, like, random people on the street who don't know about this can find the model more easily.
Right.
And can just use it and don't have to know that something annotated one thing is the same as the other, and like there's a REST API that you can use to find out what the Kebi term is for this. The disadvantage is that you've sort of frozen it in time, like this is our current knowledge of the mapping.
Right.
As opposed, and like if Kebi like later adds a thing, then that information wouldn't be added,
Right.
So that would indicate to me that you could just. Like as a database provider, you could say like, put them all in and then periodically just. Rerun your searches and say like, what new thing is now mapped to this, or what old mapping is now. Like considered wrong or something, right? So you have. like biomodels or big or whatever, like has their current version of each model that has the latest
I
information.
don't think these resources change that frequently.
Probably not, but
Do they have about education?
I don't think they update anything.
I think ever.
No, that's not true. I mean, Unipro adds new things.
So what does it look like for someone trying to annotate the model? Would they annotate their one preferred resource and then you have this REST API that you're like, read my annotations?
And fill in all the other.
Yeah.
And I can imagine that a useful tool like that, yeah, that someone knowledgeable could write it and then you say like, as part of the submissions, the big, as part of the submission to biomodels, it like slurps everything in and goes, here's your fully annotated version
Right.
now.
Which is like current snapshot based
Right.
on the
But
current
I
mapping.
don't think there are that many mappings.
Yeah,
Is one of the issues.
Yeah, I mean, I think like individual labs will annotate a model in a way that using the resources that make sense for them to read, to use.
Right.
It'd be great to have some kind of tool like you just described that will
Yeah.
swoop in.
slurp and everything
all the
else,
mapping.
yeah.
But then who's incentivized to maintain the mappings, create the mappings?
Right.
Yeah,
I think that's,
that's when it's creating.
Yeah.
yeah, I mean,
Is it BioPortal? I mean, like
I think BioPortal is somebody,
Is one.
is a group that should be doing that.
Right.
Certainly has done it to some degree.
But
And,
I don't know, are they,
also, I think like RIA has pointers to other things, I know.
well, and like BioPortal, I don't think connects up with K. Right, because
Oh, is that true?
BioPortal is like an apology, right? I don't know. I didn't think that they connected with K.
Yeah, okay.
Okay,
Well, at least not in the mappings.
yeah, okay,
Okay.
yeah, that's not there. So that's a problem.
Mhm.
Oh, what the heck?
Keg itself might map to other things though.
Tag itself.
So there's another thing the tool would know, like, oh, for keg, I have to go here.
Be like multiple mapping.
Yeah,
Yeah.
I mean, KEG for a long time was proprietary, and it may still be.
Yeah, part of it is proprietary. We looked
So-
into that.
so yeah, currently keg is less proprietary than it used to be, but
So I have a question. I mean, I'm not sure what this exercise is for. I mean, we have a number of resources that can be used to annotate. Are we trying to restrict what they are, or?
wondering what best practices is, I think.
Yeah, right, actually the opposite. I think we used to restrict what they were, and in fact, the Omics metadata specification has a list of preferred resources. And what I'm saying is, I think we should be more open and allow a wider range of preferred resources.
So I have a few proposals.
Or,
For the top level model, you should also add DOI, because not everything is indexed in PubMed, and also not everything has a DOI. So those two are actually, the
excellent,
union of those two is what you need to reference papers. And still, papers are not, some papers are not citable either with one or the other, but those two cover most things.
Yeah.
I
The
can
other
say
thing
even in the bio models, there's like 2 or 3 that aren't neither in PubMed or DOI
Yeah,
right
it
now.
could be a book, so you might need an ISSN. So there's a bunch of things. The other thing is for annotating genes, I normally prefer a model organism gene database if one exists. So for the model organisms, for example, if it's a mouse gene, I would use the mouse genome database. If it's a Drosophila gene, I would use Flybase and things like that. Those are much better curated than,
so
I
Unipro,
don't know what is the other option even there.
or
No, Uniprot is for
NCBI,
proteins. Yeah, KEG gene is NCBI gene. Yeah, I don't know. I think the model organisms have communities that put a lot of effort in curation, and they're probably the best resources. But they are normally mapped to each other. I mean, they normally map to GenBank, but GenBank is not a database of genes. It's a database of sequences. It's a very different thing.
right,
I mean, for proteins, definitely Uniprot. That's by miles the best curated resource of all of the ones you put in there anyway. But
right. But for what you propose for genes, though, is kind of challenging because there's at least, 10 different model organisms.
Oh, yeah. And then there's organisms that are not model organisms, and they still have genes. So, for bacterial species, there are bacterial species that are not well described, but their genes are.
Right.
What if you have a model that's not like taxon specific, like it's like for a mammalian system?
Right. Well, so that's what the protein ontology is supposed to be for.
For proteins, but what about genes?
Yeah, I don't know.
Yeah, but
Well,
it's no different, the genes and the proteins. The only difference is that UniProt does a good job of curating all the organisms that come across them, whereas the gene database is, I don't know.
that's kind of the opposite question. Suppose you have a model that is not organism specific.
Yeah, then you try, if it's not organism specific, I would probably try to use gene ontology. Because then there is not a specific gene, right? It's a super class of genes. In fact, there may not even be
Generic organism.
homologs in all the species anyway.
Like mammalia versus.
So it's a generic mammalia.
Yeah.
Oh, right. Yeah, we do that.
But also there are other things missing. So for example, if it's microRNAs, many of those databases don't include microRNAs. Some of the species specific actually do, but not all of them either. So again, it's the same. I think there's an enormous number of exceptions. So you end up having to look at things that you didn't think about. I mean, I've had to do that.
There won't be many generic models.
Well, I don't know, going through the.
They're more like conceptual models than rather specific ones.
I don't know, I think the last time I went through, the biomodels database, they have the taxon annotation. There's a few of them that were, like mammalia, they're not specific.
Yeah, but you went to the original paper, maybe specific. No, I don't know.
It could be that there's like just two,
You remember seeing them, yeah.
In those cases, then I'll go back to the source paper to check.
Yeah.
I mean, it's an odd thing to do, all the way from what's the lowest mammalian thing, all the way to humans.
There's also a database of cell lines called Cellosaurus. I think it's called Cellosaurus. That's for cell lines, which is quite important because a lot of experimental work is done on cell lines rather than on primary tissues.
Yeah, but
It's called Cellosaurus. Let me check.
Yeah, but if the cell line is from human, it's got the same genetic constitution as a normal human.
Yep. Cellosaurus.
Crazy. They don't have
They don't have extra genes though.
Well,
they have multiple copies of current genes, and they have a lot of things that are missing entirely.
They may have missing ones,
Yeah.
but if there's a gene there, it's the same as a human gene. They
so
may
one
have
of the things I
extra
forgot
genes.
about was cell.
I've entered it in the model top level because usually those are at the top level. It's called Cellosaurus. Yeah.
I guess if they have mutated genes,
Which they have a lot of that.
yeah.
Yeah.
The cell type ontology between cell lines.
Yes.
But you're talking about in Cellosaurus, it's a gene resource?
No, it's a cell line resource. Just go to cellosaurus.org and you'll check it.
So there's two things. You might annotate against the model, indicating that the model is for a particular cell line. You might also annotate like a multi-cell model to indicate what type of cell you're talking about. And then it would be a species annotation, right?
Yeah, it could be.
No?
I mean, I species that
So-
do like molecular.
No, but suppose you have a cell,
Oh, you're talking about this one.
yeah, physical entities in a multi-cell model, and you want to say this kind of cell interacts with this kind of cell.
Yeah, so instead of having reaction to processes in this document, or reactions and, species, you should change that to physical entities.
Physical entities. Yeah, you're right. I'm using a
But-
Yes, we know.
And I think in the metadata spec, we weren't super prescriptive about like saying, you know, you should definitely use this ontology for
I know.
small molecules, things like that. We were pretty soft about that, as I remember.
Right.
And so in the next version, I think it would be great to break things up this way, write a table that says,
Right.
here are some, you know.
And especially if I could get
resources
cross
to use for-
information, yeah.
And here's the scope of what you can annotate with those resources.
Right.
'Cause, yeah,
Yeah, one of the things we'd like to have is the ability for any annotation tool to validate saying, hey, you're annotating a reaction and yet you're providing a physical entity resource. It doesn't make sense if you have a reaction in SPML or a process in CellML to say that this is annotated against something in Kevin. Because Kevin doesn't have any reactions. So that kind of checking could happen if we have a categorization or an organization of these resources. To indicate what kind of things make sense to annotate against what kind of things.
it'd be interesting to ping the community to see, you know, what resources they're using.
Right, and that's why I flashed this. I mean, this is an analysis of biomodels.
That basically is the only convention of music.
Well,
yeah.
big,
Oh, no.
oh, big,
Yeah, but that's journalism, you
There's
don't want to do
the-
that one.
but that's very different, a totally different set of resources than that, and there's. The other one I looked at was Cell Collective. And they annotate, the interesting thing about Cell Collective
Okay.
is they use, PubMed IDs to describe reactions a lot. Yeah, so they have a PubMed ID for the overall model. And then, and remember, this is sort of a much more broad model than they're used to. And so then for each reaction, or it's not a reaction, that's the point. It's sort of an interaction or a possible,
I think that's PubMed ID.
they have PubMed IDs for.
Which references a paper,
Yep.
Yeah,
and
Totally,
there's some interaction described in that paper.
Yep.
that's really
Okay,
evidence.
extremely vague.
That's more evidence, really, than
well, yeah,
that's supporting evidence.
Right,
rather than
that's the
actual
point.
thing.
they want to document that this reaction is supported by this paper.
Yeah, you know, I've been in projects that people just read your papers and like, that's evidence. It's good to keep that.
Right,
You need that as well, but you might need a.
It's more vague.
If you're defining the semantics of something.
You have to read through the paper now to figure out, well, what was it then?
right, well, all PubMed IDs are, I mean, well,
There's a lot of like picking and choosing the reaction just to make your model work, right? So you read through like 10 papers and you're like, hey, that one supports my reaction.
the reaction, I guess.
Decided.
Good.
But ideally, they should like somehow register that as an ontology term rather than just PubMed. I'd be like, that'd be a step improved.
Well, yeah, it should be an annotation.
Mhm.
Absolutely. And we can do that, that's what is described by this form. It's not quite as explicit as is evidence form. But it seems to me.
I think it would be good to get a sense from the broader community of what resources people are using, because if we create that table, then we can see where the mappings need to exist. We don't have to guess, because like mapping, everything is huge, you know, it's kind of a sort of problem. That if it's just a matter of mapping K to Kevi, you know, or like Uber onto the FMA, we can focus on that, and that seems much more manageable.
So here's one, for example, that I know is used a fair bit in biomodels, is the beneficial ontology. And it's, so KEGG, for example, is well used. But KEGG is divided crisply into KEGG compound, KEGG reaction, KEGG pathway, and have different prefixes to their IDs, depending on which part of KEGG they're in. Branded tissue ontology seems to be an ontology that has a lot of stuff, and I think systems biology ontology has this as well, and it's not well divided. So that's kind of a challenge, a problem. I don't know if there are any BTO users here.
So it seems like the main challenge is creating that mapping, right? Because
Yeah.
if we have a mapping, someone wants to use their you know, whatever term it is, there's a mapping. And so you can't exactly map an entire DB to another DB, right? You
Right,
actually have to do single
Yes,
annotations.
Right.
That's it, yeah, it's fast.
Like it's
Manual,
manual
like-
versus automatable, is that what you're saying?
Yeah, you can't just say like, you know.
well, no, they're,
Yeah, well, I
they
mean,
are-
maybe ChatGPT can figure it out.
well, I think that, I mean, that is what the bioportal tried to do. It's an automated system for finding similarity, and they didn't just. So obviously the names is a big component of that, but it's not just the names, it's also where it fits in the file.
Mm.
But you can use to try to find things together.
And if you want to do the math, and you'd say what DB this term comes from ontology. Get the term,
It might be,
you have to, an ID, you have to go into this map, into the mapping. Find it and see if it connects to anything else.
well, that was the interface I just showed you
Yeah,
in bioportal.
so what's the challenge there is building this. Complex map, probably manually at first. And maybe.
Well, I think we can
ChatGPT build
leverage-
some
I
stuff,
think we
right?
can-
But
I think we can leverage what's been done at bioportal, right? So as I said, they have this mapping capability. And you can do this, you know, Uber onto FMA, and you can, you know, we can query,
Is there like a REST API for that?
yeah,
Here, okay. Yeah, here it is. What else? is needed?
well, as Max said, the first thing we need to know is there's, you know, I don't know, 30 resources here, and we need to know which ones are, does the community think are important. And one way to get that is just by looking at big biomodels. Cell collective, I don't know what other places I should look for models, and then we can, you know, snarf up what they annotate against, and
Those
do a count.
SLML models, if you wanted to,
And sell a mail model.
yeah.
And then you have to add them to make sure that they are in. In bioportal.
No, well, yeah, so then it's a separate issue for K, for example. Bioport is pretty exclusive, pretty inclusive, it includes pretty much everything, but there are some things that are missing, a few things, K.
So if we knew what the majority of the annotations are. We could go at least advocate.
Oh, I know another one
add
that's
it to
gonna be missing,
bioportal, Use.
yeah, I bet you, I'm sure Ria is here, but I bet you, PC numbers are not, it's really not. So, Ria. Ria is not,
Ah,
oh. Ria is not here.
That's how they call Robert Bergdorf's.
Yeah, I don't know. Huh, never heard of this one either. Enzyme reaction ontology to annotating pressure.
That's probably EC anyway.
No, it's probably not. Look at it. Might have EC, oh, it does have EC codes as part of it. But it has a lot of other things.
That looks like it itself is a mapping, look, it has EC code and Go term, right?
Yep, you're right. I don't know where this.
well,
came
that's
from.
kind of interesting.
Yeah,
Yeah.
You have an additional mapping.
Inside the,
in-
the ontology itself, yeah.
So if I'm working on like a data integration problem, and I'm trying to map, you know, let's say gene IDs. To like Unicode IDs. Then I often use this, I'm often working in R, and I use these annotation packages that are out there for R. They're called like org.hs.eg.human or whatever. Anybody else work with these things? They're really handy, like R packages that include these kinds of mappings, and in this case, it's between different gene identifiers, you know, because. Great thing about standards is that there's so many. And it's a real problem, you know, because you'll get the data set and with some identifiers and trying to make sense of it with your own.
Is that exactly what Pedro was talking about, using organism-specific gene IDs?
No, I'm just making the point that like somebody out there is creating these annotation packages
I see.
that are in heavy use among, you know, computational biologists and who's incentivizing them to make such packages and how do they make them? You know, there are packages out there for human, for yeast, for rat, mouse, and I don't know, take a look at seems incentivized to make this stuff, you know, because they are being actively maintained and they're good.
I mean, and presumably our job is not to like write a grant to try to make a new ontology or make an ontology mapping thing, but it's just to sort of find those things and
Yeah.
point people to them and maybe write some tools to utilize them,
Right,
to
right.
make annotating things a little bit easier. So that was your sort of question about the spec itself, like what do we put in the spec, what do we recommend, things.
Right.
I remember you had a different another question also. I don't remember what it was. Didn't you have?
You guys know that,
Yeah, like,
do you know that there is a bio curation society and they have a conference that actually is going on just now?
okay.
But what do they mean by curation? You know?
What do they mean by biocuration? Curation of bioresources.
Huh.
Exactly what we're talking about.
Yeah.
That must be a fun meeting, right?
Look at you put,
Yeah,
even some of us.
yeah, it's happening right now in Italy.
Yeah.
Oh, well. I'll keep it going. Yes, we can make it good, so. Probably about 3 hours a day or something.
ISB, it's another ISB.
It's a different ISB.
Not to be confused with the Institute for Systems Biology.
Oh my God.
So can you find tracks,
What are you looking for?
like tracks or topics?
Oh, at the
Yeah, go to the conference website. And look at the program. Find it.
Schedule.
There were some headers at the top,
Good.
schedule.
Well, the
Ontological
first-
mapping. There you go.
I told you.
Yeah,
nice.
thank you.
That's great.
Yeah, like these are clearly the people to talk to. Hey, they have a lunch break too.
You have lunch break?
Yeah.
I bet you they have better lunch.
Oh, yeah.
Much probably longer.
Okay,
Standards on-
thank you very much, Pedro. That's useful. It's now, I've shared my whole screen. Oh, okay.
Yeah, but
Yeah, thank you. Put that in there. Okay. What was?
Where did you put that? Did you share that?
I put that in the Combine Slack in the Harmony channel.
Okay, I found it a little bit more about a simple standard for sharing ontology mappings. SSSOM. Here, I'll put that in the same
Yeah, you
place.
put that in the same thing.
There we go. Private notes, very good. Cool. Well, this session was a success right there. Sorry.
Thank you, Pedro.
Well, I don't know if they solved it.
No, I'm sure there's a.
But at least,
comment.
yeah,
Obviously, that's the point, right?
Yeah, they have yearly conferences to debate the problem, so it's not solved.
Exactly.
Right.
Well, we should go to this conference. Okay, thank you, or I should.
It's like not actually solve anything, like.
Yeah, but that would be great to be able to, sort of put in our, annotation recommendation document to follow practices by the society.
Sure, yeah.
Any other comments? Is Roman on?
No, I don't see Roman. Kids were clearly being obstreperous.
Or he fell asleep, right? As a man.
Or he is like, all right, I'm just going to bed.
What's the solution to it if you are trying to model something that it doesn't fit nicely? What is the protocol there?
So this raises a point that I'd like to make also. One of the other annotations I would like to have, or like people to use more often, I guess, is the DC, the double core. What's the term they use? Comment, annotation, double core, description. I think it's double core description. So, so if you're trying to model something that doesn't exist, you probably did search for it. And probably came up with something somewhat close, but really quite different. So you might annotate against that, but then you need to have sort of a meta annotation that says, hey, this is a new thing. This is not exactly a match. It's different in the following way. And I think if you're really modeling something that doesn't exist in a resource, the only solution is to use a free text description of that thing.
Well, then, and link it to a resource if you can, with like a is version of.
His version of,
Annotation, like, we had this problem when we were doing the cardiovascular modeling, because the model was broken up in, like, it modeled the aorta as the proximal aorta and the distal aorta.
right,
And those are like functional distinctions that aren't in the foundation model mechanics. There wasn't a nice, term to use for that.
because there's nothing structural about that distinguishes the
Yeah.
front
so
part and second
I
part.
imagine a lot of what you guys are running into is that the anatomy analogies are structure based, but modeling is functionally based. So that's a mismatch. And so I would start with the term request if you've got some people that are open to adding terms quickly and in ontology itself. But if not, then our approach was to create your own term, basically,
Oh, right.
call it proximal aorta, and then add annotations like has parts or, is. You try and place that within the context of an existing knowledge base, so that you have some sort of semantics attached to it,
With the cheapest position, you're just saying that it's trying to define it and that's all the original.
Right.
I'm not saying it's 1/5 of the distance from the.
Right.
Yeah.
I just want to.
Well, you might put that,
We want to go like, I want to be here, moving, which is like 1/5 of the way down.
but you could put that in a free text description.
Yeah,
Yeah.
but I can't use,
Yeah, I know.
I can't use that. I don't want to use free descriptions.
Right,
I
right.
could do that anyway. If I could use free description, I want to say.
Yeah.
So you register a new term, you like in your document, you have a new term that you can reference. It has like some key version of to the actual
Yeah.
external thing, then maybe you add additional like location information. I mean, it's in the description,
This
sounds like-
it sounds like that's a need.
they want to operate on it.
Right.
Yeah, that's the thing, right? It's kind of hard. This is something on board. You like one species. It's got hard and human hard. So like, the nature is not needed. I'm here on the load. It's kind of hard to get right to. It's the situation. And it's struggling to do it.
Yeah.
Roman's on.
So I mean,
Hi, Roman.
Oh, Roman's on?
Yeah, you just.
Oh, cool.
Yeah, our approach was to like, create this custom term and then say, it's part of, let's say, the service of the web measure goal. But it sounds like what you would need is some more predicates, like, as coordinate location. Or something that where you
Yeah, like-
enter the specific information.
Like further down, and some sort of constrain it to the right part of the thing. Proportion down from the base, or that's how we make it. So,
Yeah.
And I think that, like, I think the heart has a sort of chord system that they use. It's the base.
Save it for those, yeah.
And you can probably use that, but then that's the sort of thing, that's pretty hard, with detail.
Yeah.
And is that what you need in trying to fit the provision? Map.
When you do version of, does that work? Is that like subclassing or like subtype? You can add, I'm more familiar with like objects, like in computer science, right? So you can have a subclass, you can add new methods and new attributes to it. Okay.
Is version of, is that like saying it's a region of the pattern?
I would say is version of would be more like this is the phosphorylated version, whereas is part of would be like a sub part of this or something. I think, right? Is that the basic semantics of those?
Yeah, so you would probably want to say part of. The surface of the heart. Or part of the left.
Yeah, a part of would be subset. Version of would be like a a fundamentally different sort of thing, but basically the same thing. Like it is the heart, but it's painted blue, or
Well,
or in distress, or like
so in my revision of the qualifiers document, what I try to say is that his version of means more specific.
is more specific version. Okay. Okay.
Which is very different than is part of, which is not a specific general relationship, but it's a physical occupancy relationship.
Yeah.
So I want to, while Rahuman is on before he goes to sleep, I wanted to ask him and remind him of this 2017 work. Whoops. That analyzed what things in biomodels were annotated against what things. One of the things I said at the beginning of the session would be great if somebody else redid this in 2023. So that we'd have more up-to-date information, because what we're trying to do, Roman, is really understand what physical entities in models, what reactions in models, or what processes in models, and what model information, what's annotated against what. And can we make a nice sort of semi-comprehensive list of those resources?
And create a sort of best practices sort of thing, right?
Well, at least organize them in some way so that you're not allowed to annotate some physical process against keg compound, which is not a process.
Right.
So at least some very high level validation of what is a legal annotation. Any comments, Roman?
It posted a link.
You posted a link.
Sorry, I missed is there any question that's addressed to me?
Yeah, there's a question to you about, sort of what curators at EBI do and whether this list of resources makes sense to y'all.
Yeah, I think that makes sense. I don't see any problem with that. Reaction, we are not using KEGG often these days.
Right. So,
Right.
but there's two different questions, what's been used in the past versus what's been currently used.
Yeah.
You want both things.
So you can see, I just shared a link where we have this, our protocol SOP for
Right.
annotation. It gives you overview of
Yeah, I have seen that.
Oh, okay.
So yeah, that's true, that's helpful.
So you have the referred ontology and stuff. One thing we were mentioning, Roman, is that in the past, sort of the idea, best practices was sort of like pick the best and mostly annotate against that. But now we're wondering if it might be also a good idea to go ahead and say, if you have the same thing in multiple ontologies, to go ahead and annotate it against all of them. Everywhere you find the thing you're modeling, go ahead and stick it in.
Don't you really want someone with a tool that can?
And yes, like, and ideally you would find a tool that would automatically find that for you, as opposed to having to do it by hand, right?
Yeah, I think that would be good. So, I mean, it's really hard sometimes to be very strict. So if the search
Yeah.
does the job, or if the tool does the job, that would be great. So the resource where we look for ontology is OLS. I don't know if you've seen that. EBI, it's another EBI resource. I think we have OLS.
Yeah,
I'll share the link here in a second if you haven't seen that yet.
right, the OLS just has, well, that doesn't have all ontologies, it has a bunch of them, but.
OLS has got almost all, I would say. You would be able to find anything you want in OLS, and you get the right terminologies. That the only problem is then you need to convert that to identifiers.org URL. I was talking to Henning the other day to see if he can, because he's also the responsible for OLS, to see, sorry, not OLS, the identifiers.org, to see if we can somehow translate the normal URLs to the identifiers.org URL automatically. That then it will make life easier.
Does this have NCBI ontologies in it?
NCIT?
No. NCBI, like NCBI gene.
NCBI gene. Okay, so so the NCBI gene is not in OLS, for example. Uniprot is not in OLS because those are not ontologies, right? So you have ontologies there. You don't have Uniprot and accession numbers or reaction accession numbers. That's a different thing. So anything that is to do with ontology is all there. So here we have a mix of things. So we have for example, EC number or reactome. These are reaction databases, and these are not ontology. Reactome is not ontology. So we don't have reactome in OLS. So for reactions, we have to go here to reactome or Uniprot. But everything else on every ontology, you almost all of them you find in OLS.
Okay.
But a lot of resources need to annotate reactions, so. that's
Yes,
the problem.
of course, yes. So for reactions, you mean, of course, you listed them all here. So we could use all of these. That's totally fine. But when it's beyond reactions, if it is a process, then you need ontology term. I mean, not all of them are chemical reactions. And if it's chemical reaction, that's totally fine. I mean, models can be of changes in cell, can be proliferation, interaction of the cell.
Right.
You can have chemotherapy, whatever. So all those things, you need all the processes. Yeah, exactly. Reactions is one thing, but I mean, all the biological processes which you represent as reaction, then you need ontologies which are beyond reactions.
Switching it around, make it clear that I mean the process.
Within the ontology lookup service, are there mappings between ontologies? You
I
know,
think
say-
okay, so some ontologies they do mapping. For example, EFO, experimental factor ontology, is like a meta ontology which has somehow aligned many ontologies together. So they have lots of internal mapping. And I think the ontologies team is somehow trying to map I mean, they have tools which allow you to map different ontologies and so on. So I think not everything is mapped, but they're quite. So you should. Okay, I send you a link in the chat. Maybe if you click that, it should you take you there.
Yeah, there you go.
So are the mappings kind of, put in place depending, just when people ask for them? Or is there like a more comprehensive, effort going on to map things? Just trying to get a sense of how, who might be able to do this kind of mapping and who's incentivized to do it and.
Okay, I honestly do not know all the details, but I know that some ontologies they do the mapping properly, and some they do not. But however, these guys in the EBI, this team, and they have tools to properly map the ontologies. I don't know if they've done for everything systematically, but that is not going for it. I mean, if you want more details, you can find out what exactly is the current status, what have they done. So usually they provide support if someone wants to extend an ontology. Like say you have a bioinformatics ontology, and then you have a branch called machine learning, but now this branch needs to be expanded to many more things. So you may have different ontology which has lots and lots of details on machine learning models and types. And if you instead of building new ontology, they're just going to find a way to map and integrate the two existing ontologies. So they have tools to do that, those sort of things. And so they are building bigger, I mean, extending ontologies, but not reinventing everything, but reusing existing different ontologies and so on, take branches from different ontologies. So they have tools to do this sort of mapping and combine ontologies. So I'm sure they have ways to map two different ontologies if you want to, but I don't know if they're doing it systematically on all the ontologies they have in the database.
Gotcha. Good, thanks. You said that was the experimental factor ontology, is that right?
Experimental factor ontology here, EFO. That's the one which is integrating everything. That's a bigger project internally where they use multiple ontologies. So instead of using multiple terms, what they did is they created this big meta ontology which puts together all the relevant ontologies they need, and then they have to always annotate with EFO instead of going to different ontologies. That's what they have planned to do. Oh, just to give one just hint. So if you go to the left, then you see lots of the check boxes. If you want to stick to FMA, you can just click FMA and then it's going to show.
Yeah, but that's not what we want. We want the opposite. We want to know all of them.
Okay, that's fine. Yeah, that's good.
Ventricle is used both in the brain and the heart. We got that shows up there. So this is one of the problems of mapping based on.
Straight use.
Yeah.
Thanks, Mohammed.
Yeah.
Any other issues or comments? I mean, I think this session is more sort of a brainstorming or exploration of future work rather than something concrete.
I think the other thing is, we really need to find some real use cases for this stuff.
Well, for annotation in general, or
Yeah. Some killer app. Otherwise it'll just continue to languish in the background. Don't know what that is, though. I mean, I know there's a chicken and egg thing. It's annotated, nobody has.
Nobody can do the thing, yeah.
If it's not annotated, nobody wants to annotate it anyway.
I would assume combining models is,
Right.
is a big thing, like that's something you can do with annotation that it's really hard to do otherwise.
That'd be
Yeah.
the killer app.
Sorry, just to give you something what we're trying to do now. We are trying to use a machine learning algorithm to adapt something to someone else to automatically annotate a model. So it's going to give us all the time. It's going to be not accurate and not perfect, but it's going to give you all the ontologies, genes in the model, and then the user can just say yes, no, or pick things which are right.
Yeah.
So that's what we are aiming. So most non-curated models, they are not annotated. We're not annotated also. So if we didn't yet have, if we don't have time to curate the model, then of course they remain non-curated. Then these models are also not searchable properly because we don't have proper annotation terms. So we thought, why not automatically annotate it, even though screwed, and then get things fixed later on when we get to the curation. So we have something that is half working, that is based on something else that another team in the EBI did. So we're trying to adapt that for biomodels, and we'll have some. We'll start working on this more actively soon, and we might get something.
You're probably aware of AMAS,
Rusev's work,
what we're doing here as well, to automate. It's mainly specific to metabolic networks.
Mhm.
It's sort of simple machine learning approach. It gives
Okay.
recommendations, and then it can then put those recommendations into the final model.
All right.
The other thing I just crossed my mind is anybody asked chat if it could annotate a model?
Please annotate this model.
Chat 4 anyway.
Yeah.
It's not that great with references. And
Like make up new ones.
No, we could add that, could add, you know, the annotations to the SML file.
Right, but it's.
Yeah, but it'll
Yeah.
yesterday we tried that and it was like, oh yeah, here's your biomodel 10 and it described it, but it wasn't my biomodel 10. So it's
Similar.
Yeah, but it might give you a starting point though. I don't know how to try it, I guess.
Yeah. It sounded like what Roman mentioned didn't have this mapping in multi-ontology terms though.
Right.
It was just like generating ontology. It's almost like we'll make the model and at least we'll leave some ontology terms so that humans can understand it. But it wasn't about mapping. I think the combining models is really where that would be useful.
To have it.
If you have a number of models, they all have different annotations. What do we do?
Yeah.
That's when it'll come into play. Right, like otherwise, if there are any other applications.
Search and discovery, you know, is, your
Okay, yeah.
models on a database, you know, somewhere.
Like, what is this?
Just like if you're just searching over a database of models, be like, I want something that has enough
Mhm.
in it. You can use annotations. Yeah.
Does that, have people tried searching by annotation versus searching versus text and seeing which one is better?
So you get so what we've done, we take all of the content of DMR, all the annotations.
Yeah.
These sort of big natural language things.
Oh, okay.
Give you a lot better results.
So if the ontologies are included in your text search, then your text search will find them.
I mean, if everyone commented their models and stuff, then
Yeah.
probably could be the same.
Yeah.
We have.
Do you then pull in the information from the ontology? Oh, so all you have to do is put in the reference in your model.
Yeah.
It pulls in everything else as far as the text search goes. So if you're searching for those sorts of things, it'll find all of them. Interesting.
Well, first I asked to generate that model of glycolysis.
And then add the annotation.
Then I said to add annotations.
The other thing is that we have annotations on there
Yeah.
Like they was describing, allows you to do more sophisticated queries,
Yeah,
I think
you know, like,
Are they real?
maybe.
I should change.
yeah.
Yeah.
Do people do that? Like, are these, are there biologists who have significant queries in mind that like, I really want this particular type of thing?
I think so. I mean,
Yeah.
when the modeler goes out looking for a model, it'd be nice if they could say, I want a model that where, you know, species X and species Y are reactants in a reaction in this particular reaction. You know, I want a model that represents a reaction. This, that's my guess. I don't have hard evidence. for that,
Yeah.
but-
I mean, this community doesn't have access to the biologists, right? That's part of the problem. So
Yeah.
Max and I, or I'm giving a talk at ISB, and so maybe we'll get some answers from that community at least. Not the International Society of Biology.
Not that I-
Biology Institute.
Okay, failed to annotate fructose 6-phosphate correctly.
And ate something out there.
Did it give you an accurate?
I got glucose correct, right? I mean, it's putting in all the RDF into the SPML model.
Yeah,
ChatGPT is.
Yeah.
yeah.
I just asked it first to create a model for me of glycolysis, which it probably did.
Is it trained on the biomodels database? What's it trained on? Then.
It's on the internet as of 2020, right?
Using that.
Yeah.
Okay.
And now I asked it to add annotations, and it went ahead and added RDF annotations. It thinks it's glucose as well. But,
Oh.
I'm sorry, but there's a start though. The fact that you didn't have tried it is quite impressive.
What about you was years
You got chat 4.
Yeah,
Go on, do better.
You're so used to simulating. So,
Let's see. Well, yeah, mine refused to simulate. Yours actually.
You pretended.
I actually wrote that simulation as well. I gave it some model in antimony, rough antimony.
Yeah.
It created the correct SPML, then I asked it to simulate it. It ran a simulation, it conserved mass with the numbers away.
How's it run simulation?
Numbers up.
Magic.
It's just making them.
Not entirely
Not-
made up.
not entirely
It was
made
a
up.
task survey.
It served mass.
It followed, you know. I mean, but here that you actually changed it.
I changed it, I said change the initial conditions, rerun it,
Has never been run
it
before.
did that.
You know, make realistic dynamics. So Herbert, you said make an SBML model of black hole.
Glycolysis, yeah.
ChatGPT before it comes pre-annotated.
That's good.
Yeah.
It's so eager to please. It'll make stuff up just to make you happy.
Right.
Nice. But the other thing I was thinking about on this chat stuff, there's now an open source one that's been released, varying parameters. Like there's like 16 billion parameters. But I was wondering whether you could create specialized chats that are experts in one particular area. That
Yeah.
I mean, essentially that's stockfish for chess, right? I mean,
yeah,
right, and then, like,
becomes more.
stockfish is the computer program that is the expert at chess. It is the best chess program in the world that can regularly beat everything else. But it was trained sort of AI-ish. It wasn't even given the rules of chess to start with. It was just given positions and then like slowly,
Right.
like you can do this, you can't do this, like, okay, I guess. And it's, so yeah, like everyone, all chess analysis is of computer games is always like comparing the stockfish says do this, and they actually did this other, like.
And it was trained on like all the historical games and.
I think, no, it wasn't trained on historical games. It was given. After it got enough information, it was then played itself
Uh-huh.
for
Oh,
forever.
okay.
And then, yeah,
So like beyond.
yeah.
Well, you could train an AI on biomodels, big, etc.
Yeah, just existing things, yeah.
Yeah. Probably I don't know. No, that would work.
It was pretty, I think I've gotten what I wanted to out of this.
Right.
It's trying.
Right, well, thank you everyone for participating. I'll go ahead and stop on the recording.
See you guys, have fun.
All right, see you later, thanks.
So you can.